Recording. And yes, we are live. Assalamu alaikum, everybody. I hope you all are doing super duper well. For all those who are going to be watching the recording, welcome to the demo class number 2. For all those taking it live, of course, welcome once again. And let's jump into officially the second demo class for our AS level computer science session. All the questions will be taken in the end. I'm going to give you a 15-20 minutes time period. We're going to have a long session. I don't have any O-level class tonight, inshallah, afterwards. So don't worry. I'm going to stay back, answer all those questions which you might have, whether that's related to extracurriculars, whether that's related to LinkedIn, GitHub, whatsoever, or even if it's some random discussion about Messi being the GOAT, and of course, PlayStation versus Xbox Series X or GTA 6 or whatsoever. But for now, we're going to be jumping into the second demo class. So welcome once again. So I just pasted this picture in front of you just because I wanted to make you guys a bit happy, because you all are GOATs. Why? Because you are studying computer science. Computer science is the subject which, no matter what field everybody might be ending in, inshallah, in the future, some years, there's going to be a part of computer science taking over your job. And if you are someone who is studying computer science, you're going to learn how to use these tools before people around you. That is going to give you an end-level benefit, inshallah. So let's jump into officially the most fundamental topic of computer science, and that is coming from this concept of this light bulb. So you would have definitely seen that in your homes, you are going to have something like this light bulb. So I have like this lamp with me. Button se maine isko, I can turn it off. So like, for example, boom, turn off, turned on. So you would have definitely seen something like this, right? What is this? It's a switch. It's a switch that could be either turned on or turned off. The purpose of why I'm trying to explain this model to you today is that this light switch basically comprehends something very similar to computer science. A light switch could either have the case to be as an on, or it could have the case to be as an off. But have you ever wondered, how do these computers work? So like if I have my phone with me right now, I can take pictures, I can like use WhatsApp, I can play games, whatsoever. But how does a computer work? Have you ever thought behind, what's behind this machine? So if you ever open up a computer, and you open up that CPU, what you're going to just see is electrical components, or what we usually call as chips, या फिर CPU, या जिनको हम non-computer science people are like, oh भाई यार वो तारे शारे लगी हुई थी, and stuff like that. So how does your computer work? So the main reasoning behind how everything works is that when you look onto a computer, the computer basically works using electrical components. And definitely all of you would have studied physics in their O-levels, right? So I don't have to explain this to you, but electrical components are stuff which are basically powered using something we call as circuits. Oh, I don't know why these, so it's sort of lagging, but my bad. So it's being powered by something we call as circuits. And we studied in your O-level physics that circuits are basically those electrical components which has a switch where you could turn it on and you could turn it off, right? So a switch is apparently something which you can turn on or off. Now, the best part is that when we look onto computers and you open up all these components, like for example, if I have my iPhone with me, I open it up, you may feel like, okay, I like this is such a beautiful device created by Apple. But if I just open it up, unbox it the proper way, what I'm going to see is something like this. You see all these chips, you see all these wiring, you see these small components. These aren't components. These are basically circuits. And because we know that a circuit could either be on or it could be off, we basically came to this solution that if my computer has to do something, it could either be in the state of on or it could be in the state of off. So like if I have a circuit could either be on or off. If I have a light, the light bulb could either be on or it could be off. Or to koi teesri cheez nahi ho sakti. Like there is no possibility in the middle for a circuit to be somewhere else, right? So when we talked about computers, the computer scientists back in the 1900s, what they did was when they understood that we're going to power up the computer using circuits, and circuits are just going to have two possible states, one being on and the other being off. So they were like, okay, rather than teaching the computer on and off, which if I have to type के यार circuit number 1 को on करो, circuit number 2 को off करो, circuit number 3 को on करो, circuit number 4 को off करो, तो on off computer के लिए कोई shortcut method होना चाहिए. There should be apparently a shorter method which takes less space, which takes less energy for the computer. And then they were like, what could be more simpler than giving on and off a single digit? Like where I can say that whenever I want a specific circuit to be on, I'm basically going to call that कि computer साहब circuit को value दे दो 1. And whenever I have to turn off a circuit, I'm basically going to tell the computer साहब circuit को value 0 दे दो. So when I assume that my circuit, if there is a specific electrical circuit in my computer, which is being assigned the value as 1, it has the value as 1. It is assumed, the computer understands, okay, this person is trying to say that you turn on the circuit. Now, if this circuit was to basically turn on the lamp, it's going to turn on the lamp. And now if this lamp was turned on, if this lamp was already turned on, like I have this lamp in front of me, it's turned on. So now if I want to turn it off, and you may assume that, sir, hum to button off kar dete. So I have this button, I click on this button, and you see the light goes off. Tata bye bye. You say, sir, button press karne se light chali jati. But no. The moment you click the button, it's the same way you studied in physics ke aapka switch hota hai. The moment the switch goes off, it generates a signal to the computer where the value of that circuit changes from a 1 to a 0. Because your computer understands that whenever my circuit has the value as 0, this means that it is going to be off. And this is how computers came with the identity of 1 and 0, which you literally see everywhere when you have those crazy sort of hacking stuff or like a matrix manipulation or stuff like that. And this is the whole story behind how we came up with this binary notation. So aap sabne binary ka word suna hoga. We say that binary is the language which a computer uses to talk to each other. Or like I can in simple words say, this is the language of computer. Language of computers. So like if I talk to you guys in English right now, or if I might be talking to you guys in Urdu, कि क्या हाल है भाई ठीक हो? Or maybe if I go to Turkish, I'm like كيف नहीं वो तो Arabic हो जाएगी كيف حالك? Or like whatever language I'm sort of speaking, the language of computer is binary. And this is something even non-CS kiddos would be aware of. But the reason why it's binary, and also the reason why when we talk about binary specifically, we usually refer to the scenario of 0 and 1. The 0 and 1 basically comes from this notation that your computers are basically made up of electrical components. And because behind every electrical component, there is something known as a circuit, where a circuit could be turned on or it could be turned off. Because something could be turned on and off with only these two possible states, we sort of summarize the model into saying that an on state could be resembled with the value 1 and the off state could be resembled with the value 0. Therefore, giving birth to one type of understanding or the way of representing values on your computer, or perhaps the language of computer, which we are going to be referring to as binary. So now you might be wondering, sir, binary to samajh aa gayi hai, but yaar matlab what is binary? So this is a small example. The way binaries generally work is that a binary is a switch. So if it's off, computer assume it to be as a 0. Okay, this switch has the value 0. If it's on, the computer gives it the value 1. This means that the light switch is on. And similarly, you might not only apply this for the light bulb, it's literally for everything within your computer. You might have a fan in your MacBook or your laptop or in your computer. When it has the value 0, fan is off. When it has the value 1, it is on. You have that TV remote, you click that button. It's not like you click the button and it does some Wingardium Leviosa. It's not like that. It's like you click that button and it sends a signal to the circuit on the TV, which basically results its value changing to 1. Similarly, your phone is off. I click this button, I turn it on. So this turning it on is because this button gives it a signal where you convert the circuit to having the value of 1. So you can see that whatever happens in the world of computers, it gets summarized to two things. Your computer can only understand on and off. But rather than calling on and off in terms of English, we're going to call it in the world of computer science as 0 and 1, where 0 is going to be an off and 1 is going to be an on. Now, I know that the students who have taken O-level computer science, you might be wondering, sir, ye sab kuch to hame aata hai. Now, the thing you need to understand is that this first topic is sort of a revision of your O-level CS. But the entire first topic is going to be tested in your exams, and it has small new parts in it too. That's the reason why I'm going to be teaching it to you for you all from the basics in a way where your concepts are being clarified. Now, how many of you out here have studied computer science but understood the logic behind the zeros and one being the only states a computer can understand today? So we're going to break every chunk into such detail in order to ensure that you all understand everything in the right detail. But now you might be wondering, sir, aapne to bola hai ki okay, light switch off, light switch on. But like computer is not only talking about light, right? You're right now taking class, my face is being recorded. I might be typing, I might be doing something else. I'm opening Google browser and everything. So what you need to understand up here is that in your computers, you have thousands of such circuits. Thousands of such circuits. And the way these circuits work are that you basically tell the computer that, okay, there might be a circuit number one, circuit one. And circuit one is basically connected with circuit two. And then circuit two might be connected with circuit three. So it's like a electrical circuit being created, okay? And we may assume that these are three switches, switch number one, switch number two, switch number three. Now, when I say that switch number one is on and switch number two is off and switch number three is also off, you might tell the computer or like do programming to teach the computer that whenever circuit one is on and the two and three are off, you may call that to be as an indication to turn on the fan. For example, this is just like random example for your understanding. Similarly, we might say, okay, bro, your circuit one is on, your circuit two is also on, but your circuit three is off. Assume this to be as a signal to the computer to turn on the light, for example. Similarly, you might give your computer a signal, yeah, bro, when all the three circuits are turned on, you may assume this to be as a signal to the computer where your computer is like, okay, this might mean कि आप, what do we call it, turn on the computer, turn on the PC. But right now we have basically ticks up here, ticks and crosses. But your computer does not understand tick or crosses. What your computer understands is 0 and 1. So when we talk about these binary, or when you see these crazy set of binary numbers, how do these long thousands of numbers get formed up? Have you ever thought? It's because you have millions of such circuits combined together where they decide, okay, this circuit is going to turn on, the other two are off. This might signal it to be as a fan. And the computer then replaces the tick with a 1. So this tick gets replaced with a 1, the cross gets replaced with a 0, because we know 1 means on, 0 means off. And so you may assume that this is how your computer might come up with a signal that when you have the binary value as 1, 0, 0, this means turn on the fan. Similarly, for the other example, your computer might be now this time saying, okay, I have my circuit 1 as on, and I have my circuit 2 as on too. I have 2 of the circuits as on, whereas my third one is off. So because the third one is off, it's going to be 0. And so if I have the binary as 1, 1, 0, that might be turning on a light. And likewise, if I say that all of them are turned on, and I say that all of them have the value 1, 1, 1, we came up with the notation that, okay, when you have 1, 1, 1 as your binary number, this is an indication to the computer to turn on the PC. Now, what you need to understand before jumping ahead is that this binary is how your computer represents its way of talking to each other. It's the language of computers. So whatever you try to do on your computer, whatever you're trying to do, whether that's like programming, whether that's playing games, whether that's watching a YouTube video, or maybe that's even watching Messi top 10 goals, right? Whatever you're trying to do, your computer is always going to convert stuff into binary. And that is the main fundamental reason why I'm trying to explain how binary works and what it is. So like this is a real life example of how this whole model might work. So like you have 3 switches, एक switch on, बाकी 2 off. So one on वाले को हम 1 कर लेंगे. Because the other 2 are off, we might say that it's going to be 0, 0. So maybe 1, 0, 0 is light on. Similarly, 2 on, 1 off. That might be fan off. 3 on, that might be TV on. So you see such different combination. It's not like we came up with out of nowhere. It's basically coming from the fact that you have different amount of circuits being connected with each other. So you have hundreds and thousands of circuits being interconnected with each other, where it's not like a circuit is going to take a very large space. Like even this much small space might be a different circuit. And due to the multiple different hundreds and thousands of combinations, you might be able to do thousands of different things on a computer. And that is the main fundamental reasoning, which I know a lot of you, when you go to your colleges, when you take demo classes of other CS teachers, you're going to see they always rush it through this. You can, as Sir Suleiman mentioned, you should go have a look at how other teachers teach too, so that you understand what makes your classes different. Because these understanding fundamental points are stuff which students are never being taught. But that is what we are trying to make a difference with, to make sure you understand the why and how part. But now comes up the important point, and that is, okay, we understood that we are basically going to be studying the first topic, which is regarding data representation. When I talk about data representation, what this basically means is that we are going to be studying how does my computer represent data, or like what type of data does my computer understand, what is there in my computer, how do I, as a human who does not know how to speak in binary, I don't know binary, right? How do I communicate with the computer? That is everything we're going to be studying in the data representation topic in great detail. Now, what you need to fundamentally understand is that the very first type of the way you can talk to a computer, the way we just had a long 20 minutes discussion on, was binary, where we study that binary is basically the most fundamental way of your computer talking to each other, or perhaps in simple words, it's the language of your computer. Language of computer. So language of computer can only have two states. It could either be a 0 or it could be a 1. So whenever you're going to see answers in binary, or like computer talking to the fellow hardware piece, or like maybe your speaker talking to your CPU, it's not going to be hello bro, what's up? It's going to be like 0 1 0 0 1 0 1 0 0 0 1. So everything is going to be in terms of zeros and ones, just the way we saw 1 0 0 1 1 0 1 1 1. You don't see anything like a 2. You don't see a 3. You don't see a 4. Why? Because it's a circuit. A circuit only has on and off, 1 or 0. So we come up from that discussion to this point that you have the most basic way of talking in the world of computers through binary, where binary is only represented in either 0 or a 1. Now, you have a terminology in the world of computer science which we call as base. So you're going to see these nodes, you're going to see everything, and they refer to binary as base 2. So what do I mean by the word base? For the people who might not have studied computer science, you might be wondering, sir, base kya cheez hoti hai? Base basically means how many possible values are there. So if I talk about binary, how many possible values do we have? We have two possible values. It's either going to be a 0 or it's going to be a 1. Nothing else. 0 or 1. So when we have two possible values, we're going to call that to be as a base 2. But now what is binary? A binary is basically a number system. A number system. And what is a number system? A number system is basically a method for your computer to represent data or values, or like a method for your computer, or a specific representation for your computer to represent values. So like if I'm talking to computer, or like computer is talking to something else, वो किस तरीके से अपनी बात को comprehend कर सकता है, that is something it does through number system. And the first type of number system is binary, where your computer converts everything to zeros and ones. But now you might be wondering, sir, हम तो binary में बात नहीं करते. Like if I at this point go and tell Rayan, can you please call this friend of mine? I don't say like 0100 1010 001. I'm like speaking in English, right? Or maybe if I ask Rayan, how many marks you got in your O-level computer science paper? He might be like, I got 148. So he's talking to me in terms of integer values, 148 numbers. So it means computer should know something which we humans can understand, right? And that is where we come up with the second number system, which we call as, generally, it's normally in the world, or like in Pakistan, we usually call it as Denary. But I found it that way, that the proper pronunciation for for this word, it's not Denary, it's Denary. Okay, I found it on Google. I was shocked too, but yeah, it's Denary. Okay, so Denary or Denary, as you might hear it, Denary number system is basically that type of number system which basically represents the conventional number system. What do I mean by conventional number system? It's the number system we humans understand. So what are the digits we humans understand? We understand the digits 0, we understand the digit 1, we understand 0, 1, 2, 3, 4, 5, 6, 7, 8, and of course 9, right? So whatever number you have in this world right now, whatever mathematical number it might be, whatever score it might be, it is always going to be formed through what? It's going to be formed through these 9 to how many numbers are these? These are basically 10 numbers, 0, 1, 2, 3, so 9 and 110. So whatever number we form in this world at this point, it's going to be coming up from these 10 different digits. You combine these 10 digits and you can make up any number. So like if Rayan told me I scored 140, so where did that 140 come from? So he took this 1, he took this 4, he took this 0, he combined them and boom, I got a number with 140. But any number which we tell computer or something which we write using these 10 digits, that is basically written in a format known as Denary or Denary. So these number systems are basically languages. Just I say English, Urdu, Pashto, maybe for your computer, the different languages are binary, denary, and the third one is something we're going to be studying after this. But now your denary, if we look onto this, this is the number system which we humans understand as the conventional number system. So like if I have a specific value, maybe I say Rayan scored 140 in his O-level exams, in his O-level IGCSE exams. I hope Rayan, you get an A star, inshallah. But let's say in Rayan scored 140 out of 150. Now, if I have to go from this, I as a human understand 140. Like if I ask every one of you, 140 ka matlab aata hai, you'll be like, huh, 100%. But now the problem is, my computer sahab only understands binary. Computer sahab only understands binary. He doesn't understand anything else. So this means that we now need to understand how I need to go from the conventional number system to convert that into a number system which my computer can understand, which means that we have to go from denary and convert the values into binary, right? So that is something we're going to be jumping into in a bit of time. But just to complete the formalities for those small MCQs you might be getting on your AS level exam, you might usually be asked on what is the base for denary or denary. So I mentioned the base ka kya matlab? Possible values. So if I talk about denary number system, how many possible values do we have? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 possible values. Therefore, you have denary to be as base 10. For the students who had O-level computer science, कभी आपने सोचा कि when we say that it's base 10 number system, रट्टा लगाया होगा काफियों ने? रट्टा नहीं लगाना. That's the reasoning behind where did this base 10 come from. Base means possible values. So if you have 10 possible values, we call that number system to be as base 10 number system. And right now we have the scenario. We have Rayan score as 140 and I need to convert it into binary for my computer to understand. So we're going to be jumping into understanding how can I convert a denary number system into binary. So the first topic for today is going to be converting denary into binary. Now for the students from O-level, I know you might be saying, sir, easy scene, but we're going to still re-go through the whole process so that you understand the theory and the reasoning behind where did those values come from. So now what you need to understand is that binary is basically a set of zeros and ones. 0, 1, 0, 1, 0, 0, 1, 0. And now if I have a number like 140, how do I convert this 140 into 0, 0, 0, 0, 0, like empty slots where we could either have a 0 or we could have a 1 or something like that, right? So for that, what happens is that your computers have basically created this model where they have basically decided कि यार हम एक काम करते हैं, if I have a number, I'm going to try to fit that number in a specific shelf. So computers basically created shelves, okay, in memory. So यार ये जो आप लोग memory देखते हो ना, hard disk, SSDs and all that stuff, those hard disk and SSDs basically have shelves in them. And those shelves have basically small sections. So for example, a shelf with 8 slots, 1, 2, 3, 4, 5, 6, 7, and of course 8. So it's like a shelf, and the shelf has basically 8 small boxes in it. Now, what you need to understand is that if I generally talk about 140 as a number, like this is back from your O-level mathematics, if I talk about 140, you would have studied something like known as positions, where we say, okay, yaar, this is ones. We call this ones. We call this fours at tens position, tens, hundreds. Usually you call and you divide a number into these 3 categories, where if I want to divide this into different section, I could be like, okay, if I have to get this number, I know that this is something from O level, right? यहाँ पे 0 है, तो 0 multiply by 1, क्योंकि ones के section में, plus 4 tens है, तो 4 multiply by tens के section में, plus 1 यहाँ पे, तो 1 multiply by 100, क्योंकि 100 की position में. If I add all them up, 0 into 1 is 0, plus 4 into 10 is 40, 40 into 1 plus 100, 140, I get that number. So when we basically write these numbers, this is back into your fundamental elementary mathematical skills. You saw that whenever I have to write something, even in Denary, each of these positions, whether that's this, or even if I might come up with something like a 3 on next, which might be in the thousands position, every specific position has a different value. So you cannot say that this thousands value up here is going to be counted as 10. No, this is the 1000 position. So 3140 value hai is result. And how do I get to know this? Because when we were deriving this at the first place, we assigned them different values based upon their position. So when I have to go from 140 into binary, basically when you have to write the numbers in zeros and ones, while writing them, you usually write them in spaces known as a register. So register is basically a specific memory slot, a slot in your memory, or like it might be, you can say, ke aap logon ne, maybe if I like got glasses for myself, so I might have this, you know, the glasses ke liye जो डब्बा आते हैं जो एनको वाले आपको देते हैं, so you might get this डब्बा or box alongside, right? So when you have to store binary, it's not like you randomly tell the computer 01010000. You put the value in a specific box. That box is what we call as a register. And now in this box, you have basically these separate number of boxes. Abhi for now, there are 8 boxes. You're going to see examples, 12 boxes K, 4 boxes K, 16 boxes K, but that is stuff you're going to look into afterwards. For now, this is the point where we need to understand the concept. So when you have these 8 boxes, let's say this is box number 1, this is box number 2, box number 3, box number 4, box number 5, box number 6, box number 7, box number 8. The point is every box up here has a specific value. And you don't start 1, 2, 3 from this side if you had that question. You always start from the most right-hand side. So your starting always happens from this point. Remember this in your mind. Okay, so when you talk about binary, you start from this point. It's like the same way if I write my name in Urdu, Maaz Munir. Perhaps I forgot Muhammad, wo bhi dalna chahiye. So it's like Muhammad Maaz Munir. So yeah, if I have to write my name in Urdu, you see I start from the right side. So binary was also inspired from Urdu. He was like, okay, right side se start with it. So you have these 8 boxes. But now the way we saw that yahan pe one box has the value 1, the other has the value tens, the third one has the value hundreds, then the fourth one has the value 1000. How did these values come up? Have you ever thought about that? Have you ever thought about how? By the way, guys, is my voice lagging? Is my voice lagging? Let me open up the chat box. Can anybody kindly confirm in the chat box? Meri awaaz lag to nahi kar rahi? Fine for me? All right, perfect. That's great. Good. Perfect. All right, let's move in. So now when I have these numbers, have you ever thought ye ones, tens, hundreds, thousands, aaye kahan se? Inke piche kahani kya hai? So basically what happened is that you basically have a formula which I came up. I don't know ye formula kahin exist karte hai. If not, this is Code Catalyst Sir Mazer's formula, and I even taught it to my O-level students, where the formula for the value at each box is basically value equals to base raised to power position. Base raised to power position. Base raised to power position. So like in this case, you might do 10. If this is Denary, right? 3140. It's like formed from these 10 digits. So if you see, you basically have this value for the first position coming from the fact that it's 10 raised to power position number. Now this is where you're going to learn something new. In computers, The first digit is not 1. You don't start from 1. In the world of computer, the very first thing or the first digit is always a 0. So like if I'm counting how many pencils I might have, so like normally we humans are like 1, 2, 3. We say we have 3 pencils. But if it's a computer will not call it to be 3. Computer will be like pencil number 0, pencil number 1, pencil number 2. So your computer starts counting from 0. Keep this in your mind. So when I talk about positions, this means this is position number 0, this is position number 1, this is position number 2, and this is position number 3. So if I put the values, 10 raised to power 0 is always 1. And you get this ones from there. 10 raised to power 1, 10. There you go. You get 10 from here. 10 raised to power 2, it's 100. So you get 100 from here. 10 raised to power 3, and you get 1,000. And that's how you get these values. And you know the same notation is being used in binary too, where the exact same formula has to be used for this point. How? You see, we're having binary. We know binary is what? Binary is base 2. We just studied it, right? So you start off with this being the very base position number 0. अब यहाँ पे तो वैसे ही मैंने आप लोग के लिए बताया कि 8 डब्बे, but if it's a computer won't count it to be as 1, 2, 3. Computer would be like, nah, man, I don't understand 1, 2, 3. I start off my counting with a 0. So it's 0, 1, 2, 3, 4, 5, 6, 7 for me. So now if I assign it the values, how is it going to be? So it's going to be 2 raised to power base 2 because it's binary. Binary is base 2, right? So binary comes out to be as base 2 raised to power position. So position number 0, 2 raised to power 0 is 1. So you get 1 up here. Then moving on to the second box, 2 raised to power 1. 2 raised to power 1 is a 2. So you get a 2 up here. Moving on, 2 raised to power 2. It's a 4. So you write 4 up here. So like this box has the value 4. Then 2 raised to power 3 and the value is 8. You get the value 8 for the fourth box ideally, right? So 1, 2nd, 3rd, 4th box. Then 2 raised to power 4, it's a 16. You get the value position 16 up here. You move on, 2 raised to power 5, you get 32. And you get a 32 for this box. You do 2 raised to power 6, you get 64. And if I even do 2 raised to power 7, you get a 128. So this comes out to be as a 64, and this comes out to be as a 128. So if you look and focus upon these values, the values are just getting multiplied by 2. So you might be wondering for the non-CS guys, sir, ye ratta kaise lagayenge? Bas yaad karo 1, 1 ka double 2, 2 ka double 4, 4 ka double 8, then 8 ka double 16, 16 double 32, 64, 128. And if I have to go on, wo aage multiply hi hota jayega. But what I just did was I assigned binary some values in this box. I assigned every box a specific value. So like I have these 8 boxes in front of me with every box having a subsequent value. And now the story is very easy. How? So let me just copy it for you so that it's not making mess. But like, for example, if I just copy the upper part, नीचे वाली बात अब आप लोगों को समझ आ गई होगी. Like if I just copy this upper part, bring it down here, you're going to see that we were asked to convert the number 140. So if I have to convert the number 140 into binary, the way I'm going to follow the method behind this is that I'm now going to, because I know the values of each box, right? I know okay, har box ki kya value hai. These values you see up here, these are in Denary. So now I'm going to put 1 under all those boxes. Jiski value when I add, I should be getting 140. How? Let me solve it for you. So for example, I have a 128. So 128 ke niche if I put 1, this basically means 128 plus, I need to now put 1 under places, which gets me the answer as 140. 128 plus 64 is 192. So 192 to 140 se bada hai. I need the answer to be something where I put 1, where if I add the values jahan pe 1 1 hai, they get me 140, right? So 64 to 0 ho gaya, because I cannot add 64 into 128 to get a 140, right? Then 128 plus 32. Now, again, the value is going to be 160. I cannot get that. 0. 128 plus 60. Let's think. Again, you won't be having a calculator to save the time. I'm just doing it for my own ease, even though it might be easy. But you see, I get a 144 out of range. So that's also going to be 0. Now, let's do it for 8. 128 plus 8 is what? 2, 6. Okay, I get it to be as 136. So when I add 128 plus 8, that's a 136. Now, what do I add again into 136? So I get a 140. I put a 1 up here. And so 1, why? Because this has the value of 4. Because when I add all of them, when I add all of them, 128 plus 8 plus 4, you can see that I get my answer to be as 140. Then should I add a 2 into it? No, right? So put a 0. Should I add a 1 into this? No, because the value is already 140. So this answer which I just got is basically how you might be able to represent the Denary 140 in terms of binary 10001100, where you can clearly see that what I just did was I placed 1 under all those boxes values, which when I add them up, I should be getting 140. So now if I add these subsequent values, 128 plus 8 plus 4, you can see that when I do this calculation, I get the answer to be as 140. I get the answer as 140. And now that's how you basically convert a Denary number system into binary. Simple. Nothing crazy. You just basically write the values. You write the values and you basically just fill it up with values in order to ensure that you get the answer the right way. So I'm going to do another example, and then I'm going to take some questions if you guys have in regards to what we just studied. So I'm going to appreciate the questions stay relevant to what we just studied. Anything jo uske bagair hai, I'm going to give you 15 minutes in the end, inshallah. Detail se pooch lena, koi jaldi nahi. Okay. So for example, we have the value 78. I need to convert 78 into binary. I basically created this register shelf, assigned them the boxes, their specific values, 1, 2, 4, 8, 16, 32, 64, 128. Over time, once you start practicing, aapko khud yaad ho jayega. You're going to self-memorize it. Okay? It's not that complex. But yeah, you have the formula of bhul gaye, base raised to power position, and you're good to go. And now, I'm going to basically put ones under all those places, which when I later on add them up, I should be getting a 78. How do I do it? Easy. Let's start off. So 78, first rule, you start off from the most left-hand side. So this is the shortcut. If this value is smaller than the number up here, then it's definitely a 0. Why? Because you cannot do something like 128 plus some positive number to get a 78. Yeah, negative numbers possible, but we don't have negative numbers as of now, right? We're going to discuss them in the upcoming classes. For now, no negative numbers. So you put a 0 up here. 64 less than 78, of course, we can put a 1 up here. So 64 plus, now I need to add something into 64 so that I get a 78. I know that it has to be what? It has to be 40. So I need to basically put 1 so that I get 14. So kya 32 isme add karu, that's 96 greater than 78. This has to be a 0. 16 add karu, 64 plus 6 is 70. 70 plus 10 is 80. Nah, miss. 8 add ho sakte. Of course, 64 plus 8 is 72. So I got to 72. Now I need to basically add 6 into it. So 6 kis tarah add hoga? I can add 4, making it 76. And 76 plus 2 is 78. And so I got 78, right? So yahan pe 1 add karne ki zarurat hai? Not at all. So you see that I just got my binary answer to be as 01001110. And how do I check it? You check it by adding the values of the places where you press a 1 value. So now, हमने कहाँ पे 1 किए? The places I've highlighted. So 64 plus 8 plus 4 plus 2. And you can check it this way. 64 plus 4 plus 2 is 6. So 6 plus 64 is 70. 70 plus 8 is basically 78. Hence verify that yes, this binary is 100% correct. And that is how you basically go from the number system you humans understand, which we call as Denary, and we convert that into the basic fundamental of computers binary. So now if you might be having a quiz, and quiz mein aapke marks 0, 1, 0, 0, 1, 1, 1, 0 likhe ho, so don't text me saying, sir, why is it binary numbers? It's because an extra test for you to convert it on your own to Denary, ताकि आप अपने marks खुद evaluate करें. We can have some crazy stuff like this. Like you guys are gonna love these classes, inshallah. Once we go a bit deeper into it, जो बाकी आगे वाले topics, we get some crazy examples, inshallah. Okay, but that is how you convert Denary into binary. Now I'm opening up the chat box. If there are any questions in regards to this conversion, you may ask them. If not, I expect every single one of you to spam the word clear in the chat box so I know that you guys are clear so that we can proceed with the next subtopic. Shabash. Perfect, mashallah. That's great. Shabash. The people who had computers, who did not have computer science in their O levels, I also expected कि आप लोग को भी समझ आ गई होगी. If there are any questions, don't worry. How to convert binary to Denary? अभी उसी पे जा रहे हैं. Yusuf साहब, stay chill. Whatever I'm teaching, just stay relevant. So ये आपको बस ये समझनी चाहिए कि the way Iman asked that if computer cannot understand other numbers, how can they understand ones and zero? It's basically computer cannot understand one and zero. It was like we taught them that when the circuit is turned on, the humans are going to refer to that as a one. When the circuit is turned off, we humans are going to call that as a zero. तो हमने अपने आसानी के लिए बाइनरी बनाई है, and we basically ensured that your computer, when it says कि circuit के अंदर electrons जा रहे हैं, physics, when the circuit has electrons going in them, they're going to tell me by telling me कि यार it has the value one, so that if I'm coding programming, so I'm basically going to be making use of those ones and zero to understand कि कौन सा circuit on है और off है. Computer के अंदर it's not going to be like computer को one and zero समझ आ रही है. Computer को क्या समझ आएगी? सर्किट में बिजली जा रही है, सर्किट में बिजली नहीं जा रही, इलेक्ट्रॉन्स का फ्लो. सो व्हेन देयर इलेक्ट्रॉन्स आर फ्लोइंग, इट्स अ वन. इलेक्ट्रॉन्स नॉट फ्लोइंग, जीरो. सो वन एंड जीरो इज फॉर आवर ओन ईज, ताकि हमें समझ आए. क्योंकि आपको माय बैड, so I just threw the whole pen, but yeah. So now if your computer was to represent these in on and off, तो कितना on off तो लंबा हो जाता. तो हमने शॉर्टकट में 0 and 1 कर दिया. Simple, right? So now we're going to be continuing to the other part. Okay, you know binary. You have Denary. We learn how to go from Denary to binary. What if I say that no, बच्चों अब तो बारी उल्टी आ गई. आप लोगों ने पहला quiz दिया and I gave you the marks in terms of binary. And now you need to go from binary to Denary, because we humans do not understand what's binary, right? So like if somebody tells you that there is this binary value 0 0 1 0 1 0 1 0 2 4 6 8. Okay, so right now we are assuming it's again 8 only digits of binary. So we are only talking with 8 binary digits. And now when I talk and say that it's basically 8 binary digits, like you say कि हमारे पास सिर्फ 8 binary digits हैं, we call such a register to be an 8-bit binary register. Jitne number of binary digits honge, like in this case, this scenario which we are sort of discussing at this point, it can maximum have 1 2 3 4 5 6 7 8 binary digits. Hence we say that it's a 8-bit register. Agar 12 binary digits ho de, which is something we're going to see in the upcoming classes, we call that register to be as a 12-bit register. 4 binary digits होते, we call that as a 4-bit register. तो ये जहन में रखना, because ये question exam में usually होते हैं. सही है? So now if you have binary to then, you have this binary number. Let's suppose this is basically the score of Maheen in the very first quiz, for example. Okay, so it's Maheen's quiz number 1 score, and now I gave Maheen the score in terms of binary. Maheen was like, okay, I need to convert it into Denary. यार एक तो सर भी यार वक्त practice करा रहे हैं, मतलब पागल हो गई हूँ मैं. But yeah, how is Maheen going to go from this to this? So what Maheen needs to do is the same register which I created. She needs to just copy that up and recreate it. She just needs to recreate it. So I'm not going to waste the time making the boxes again, but you might assume that she goes and she creates this exact same register. So ye sare hata do. It's empty. It has nothing inside it. But yeah, Maheen just created a register like this. And now she's going to put this value inside this. So she's just going to plug this value into this register. So 0, 0, 1, 0, 1, 0, 1, 0. So we basically just copied the binary value you see up here into this register. Now, how do you convert it into Denary? The same thing using which we were testing. All the places where you have a 1, you basically add uski value. So 1, 1, 1. So we have 1, 1, and 1 at these slots. So jahan pe 1 hai, we're going to just add those values. What are the values? 32 being added into an 8, being added into a 2. So we add the values jo hum upar likhte hain. And if you calculate there, it's 32 plus 8, 40. 40 plus 2 is 42. So Maheen scored 42. Right? So that's how you basically convert a binary number into Denary number. अब हर जगह आपको ये इस तरह का बना के नहीं दिया जाएगा. So like if you get a question where they ask you directly कि there is a value 1 0 1 1 0 1 0 1 1 2 3 4 5 6 7, okay, and you are asked to convert this into Denary. So in exam, the way you are going to be doing it is that with practice you're going to be given working space. उधर आप इसको openly थोड़ा लिखोगे 1 0 1 1 0 1 0 1. हर digit के ऊपर उसकी value and position value लिख दो. So you know this is the starting position. We know from the above scenario it's going to have the value of 1. Kis tarah? The formula which we discussed just beforehand, right? So it's going to be 1, 2, 4, 8, 16, 32, 64, and 128. And now all those places where we have a 1 beneath it, we're going to just add those. So 1, 1, 1, 1, 1. So now I'm just going to be adding the values of the places where you have a 128 plus a 32 plus a 16 plus a 4 plus a 1. Keep it in your mind that no calculators are allowed. So you are expected to have strong mathematical addition, subtraction, division, multiplication skills in order to ace your A-level computer science exam paper, right? So if you just add them up, you're the basic, yeah, but yeah, still, right? People mess it up. So don't rush. Aram se 128 plus 32. So it's going to be 130, 160. So it's 160 plus 16 plus 4 is 20. And that being added into 1. So it's going to be 160 plus 20, 180, 180 plus 1, 181. And that is how you basically convert a binary number into Denary number. So if a computer science major tells you some sort of binary number, which is basically a base 2 number system, and asks you to convert that into a base 10 number system, which people who haven't even studied computer science or like the non-CS people, ab to jinne nahi bhi padhi, aap log bhi CS people ban gaye, okay? So don't be like non-CS people mein aap log aa rahe. So the people who haven't studied CS or the people who are currently studying CS, so आप लोग बेस 2 को समझ लोगे by converting it into Denary. But जिनने नहीं पढ़ी होगी, they'll be like, यार ये क्या हो रहा है? So now if you guys want to have that chit chat with each other and want to yap and like, you know, share that tea with each other, so you can also share the tea in binary. So yeah, if it's something like you can comprehend that in numbers. But that's how you convert binary numbers into Denary. I'm opening up the chat box once again. If it's a clear, I expect every single one of you to send the message clear. If there are any questions in regards to this, please send the message in the chat box so that I can basically re-explain. Otherwise, we're going to then move on to the third number system, which is out there in your syllabus. Perfect. Now, another important thing about our classes, I expect every single one of you to send the clear message. सही है, वरना मैं नामों से बुलाने लग जाता हूँ. The students who have been taking my O-level classes, they know me pretty well. I'm like, बताओ आपको समझ आई या नहीं समझ आई? So every single one of you, आप लोगों ने सोना नहीं है, and you don't have to lay over your bed. Perhaps अपने fingers को उठाओ and you just write clear, so that I get to know that everybody is on the same page, so that we can move on. If there is anybody who faces any problem, don't be like सबको समझ आ गई. Of course, maybe आपको समझ ना आए. Ask me 1,000 times, and I'm basically going to be always trying to explain it to you. How exactly do the CPU and transistor use 0 and 1 to carry out instruction? Whoever not relevant, okay, koi masle ki baat nahi hai. It's not something relevant and not something you're going to study at A levels. This is something you're going to jump into more in university. But if you looked onto this part of the class, it's basically this way. Aapke wo zeros and ones basically comprehend different circuits being turned on and off, and using the combinations of different circuits being turned on and turned off, we basically have different components being turned on. So like you might say circuit 1 on, circuit 2, 3 off. So 1, 0, 0 is a signal to turn on the fan. 1, 1, 0 is basically a signal to turn on light. 111 might be a signal to turn on the PC, and so on. You can have thousands and hundreds and thousands, but it's a very simple alfaz mein maine aapko samjhaya ki how it's basically going to be carried out. So for the people who joined in late, you guys missed a big session, a very important fun session. Oh yaar, miss karte hain. But never mind, the recording would be uploaded, so chill scene hai. You guys can join in. We have just covered up the conversions. If you have studied CS in O levels, samajh aa rahi hogi, but still, if you want us to watch from the start, the recording, inshallah ta'ala, would be uploaded by midnight. You can watch it and then join us tomorrow for our last demo class. Okay, so we just studied the 2 ways of representing numbers in a computer. We studied 2 ways of representing numbers. One is the binary, the other is the Denary. We studied binary to Denary, and we now also studied Denary to binary. Now we're going to be jumping into the third type of number system which your computers can comprehend. So your computers understand 3 languages. Language number 1 is binary. Language number 2 is Denary. अब वो ये नहीं होता कि उसको Denary number समझ आती है. It basically translates the Denary into your binary. So you may assume कि उसको language नहीं आती. It has a translator which can convert that binary into Denary. Okay, and similarly, the third type of language जिसका translator उसके पास मौजूद है, that's known as hexadecimal. Hexadecimal. And when I talk about hexadecimal number system is a unique number system where you might be saying, sorry, ye kya drone numbers aap le? Nahin. So hexadecimal is basically something which computer scientists introduced, because when we were talking about the Denary number system, you could only represent digits from 0 to 9. You could only go from 0 to 9. But like computer scientists were like, nahi yaar, we have to bring up new things too. Like 0 to 9 does not fulfill all of our requirements. What if I need koi number 10, 11? Like I need a single digit number for 10, single digit number for 11, something like that, right? So they were like, can we not extend 0 to 9? Now the problem was that computers could only accommodate a single digit. Well, अगर ये जगह यहाँ पे 9 आ सकता है and दूसरे वाले में let's say, या फिर let's say पहले वाले में 1 आ सकता है, दूसरे वाले में 2 आ सकता है, to make it 12, right? But computer scientists were like, can we not make something where in this one single place we both fit 1 and 2? Which was not possible when we were talking about Denary, okay? Because आप एक slot में दो Denary digits को नहीं fit कर सकते. So what computer scientists did was, they were like, let's come up with hexadecimal. Where what we can do is, okay, we might not be able to fit 12 in a single slot. But what if I say, क्या हम 12 को ना एक नाम देते हैं, like something like, for example, अगर यहाँ पे हम 10 कर रहे हैं, ताकि वो फिर आपको सारा concept भी समझ आए. So if I have to fit this 10, I cannot fit 10. But what I can do is कि मैं 10 को एक नाम दे देता हूँ. अब digits तो सारे occupy हो गए. So this means we have to go towards the English letters, right? So we say, why not we call 10 to be as in letter A? अब यहाँ पे एक चीज तो आ सकती है. So I can put in A and I can teach my computer that wherever you see the letter A, assume that the value A has the value 10 in terms of tenary. So A की value क्या होगी? 10. But it's no longer occupying two slots. हमने एक ही slot के ऊपर A कर दिया, which is something beneficial for me because I'm no longer occupying more positions. I'm no longer writing multiple digits. I'm sort of bringing everything down to smaller chunks. And so you saw that I basically wrote A as 10. Similarly, computer scientists were like, okay, A as 10 कर दिया, let's move on. 11 को हम B लिख देते, 12 को हम C लिख देते, 13 को हम D लिख देते, and then 14 को हम E लिख देते. And then they were like, okay यार बस बहुत हो गया, but चलो 15 को हम F कर देते. They came up with this new notation where they assigned values to letters so that these letters could be written in terms of the double position. And so your hexadecimal number system is that number system where you can write values using 0 to 9 number system like normally, like Denary में, but you also have an additional list. So like maybe जैसे मैं बोलूँ कि Urdu and Hindi is pretty much similar, right? In terms of speaking, you might watch Indian movie, आपको full समझ आ रही होगी कि क्या बोल रहे हैं, but it has like a small set of new vocabulary which you attach to it. So similarly, hexadecimal was like Denary का latest version. How it was Denary को आपने लिया, but I was like, okay, let's add these ABC वाला part to it. And so they basically added the A to F part next to it. So hexadecimal number system is basically that number system which gives you basically how many possible values? They give you first 10 possible values from 0 to 9, 10 possible values here, and then if you count this 11, 1, 2, 3, 4, 5, 6, 6 आपकी ये possible values होगी. So it's basically giving you 16 unique values, and because it has 16 unique values, we call this to be a base 16 number system. Base 16 number system. So if ever in exam you see the word saying hexadecimal is base dash number system, so you should know base 16. Why? Because it can have 16 different values. So like a hexadecimal number might be written something like as 7A. Why is this a hexadecimal number system? How do I get to know this? I get to know this because is this 7 from the possible 16 values a hexadecimal could be written in. So like hexadecimal किन value से बन सकता है? That's the question. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, and F. So any value which is basically created from this list can be a hexadecimal value. Matlab I just wrote 7A, that's a hexadecimal value. I might write something to be as AC, that might be a hexadecimal value. Why? Because AB यहाँ से C, B से C. Similar to saying जैसे हम Denary में क्या कर रहे थे? Denary में we add the numbers at 0 से 9 तक, right? We add the numbers at from 0 to 9. So when I write 140, ये 140 कहाँ से आया? So I basically brought this 1 यहाँ से, I got this 4 यहाँ से, I got this 0, and I merged them. Similarly, hexadecimal में if I have to write different things, AC, A यहाँ से, C यहाँ से. I might do something like 3F6. 3 यहाँ से उड़ाया, F यहाँ से उड़ाया, 6 यहाँ से उड़ाया. So if I'm staying within the list of these possible 16 values and I generate a value, that value is what I can call as a hexadecimal value. And there are a lot of usages of these hexadecimal value, which we are going to be, inshallah ta'ala, discussing in tomorrow's class. But for now, we are going to understand, okay, bhai sahab, computer ko to samjha diya ki, okay, there is hexadecimal value. But the problem is, computers aapko to, ab yahan pe do masle. We as humans don't understand hexadecimal. हमें तो numbers ही conventional number system, we only understand Denary. So we have to study hexadecimal to Denary. And we also have to study कि भाई computer को तो circuits में 0 and 1 की शक्ल नहीं समझ आनी है. So we also need to study how to go from hexadecimal to binary. So that is what we are going to be just studying. So we are going to be first studying the conversion of hexadecimal into binary, the most fundamental. So आपके computer को power up करने के लिए hexadecimal being converted into binary. How does your computer understand a hexadecimal value? Now for this, there's a very easy shortcut. Very easy shortcut. Let's suppose there is a value 7a. Now what you need to understand is that when we have a hexadecimal number, the way you're going to convert a hexadecimal number into binary is that if I bring this number in the center for you all, the first action is that you split the two alag alag. You become that divider in between, you're like crass, tod diya. So yeah, so you bring this 7 separate and you bring this a separate. And then you convert each of them to its subsequent binary value. So I convert 7 into binary and I convert a into binary. But you might be wondering, sir, a की तो मुझे value नहीं पता. So अब यहाँ पे हमने ये chart याद करना है हमेशा कि a की value is always going to be 10, b की value is always going to be 11, c की value is always going to be 12, d की value is always going to be 13, e की value is always going to be 14, and of course f की value is always going to be 15. So 10 to 15 this way. So I know that if it's a, I can write this a to be as 10, right? So now I have to basically first you break. Step number 1 is you break, or you may say, okay, you split the values. Step number 2 is you now write or convert into binary separately. So now you see you have the values in Denary form. And we just studied how binary made Denary. Oh my bad. Binary. So like we just studied how you convert a binary number, a Denary number into binary, right? So aap values position likhte ho. So like if I have to do this separately and this separately, now what you need to understand is that when you're talking with hexadecimal values are always very small. They are always very small. So when you usually get digits, these digits are less than 10, right? It's like 7, 10, yeah, maximum they ja rahe hain 15. So in the first example, we saw that the values which we were taking, like for the positions, they were going somewhere like 1, 2, 4, 8, 16, 32, and so on. They went on to 128, right? But because in our case, when we are talking about hexadecimal, the largest value that could be written in hexadecimal is a f. And a f could be represented as 15. So हमें इतनी बड़ी values तक जाना ही नहीं है. We want a maximum slot where maximum we can represent 15. इससे बड़ी value हमारे पास वैसे भी नहीं होगी. So all these numbers are basically something which we are going to be representing. But when we are writing them in binary, अब वही same logic, you're going to make those slots, say same to same slots, and you're going to assign the value. Those values, because these are very small values, you can only go till 8. So 1, 2, 4, 8. And then similarly, just like before, 1, 2, 4, 8. So it's like jo hamare paas, when we were learning the conversion from a binary to Denary, we went for 8 bits. But right now, because we only need a small portion of it, so what we are just doing is we are just counting this minute chunk of it. So we are no longer jumping into the longer part. We are like, okay, let's just deal with these small 4 boxes. Because if all these small boxes are basically filled up with 1, this could be 1 kar do, and this could be 1 kar do, and you add all of them. 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So that is within the max range, because I know that the maximum I'm going to represent is a 15. So like all my values in this hexadecimal case is always going to be converted into 4 bits. 4 bits, 4 bits ki binary. So now I'm going to convert 7 into binary. How? Ye to 0 ho gaya. 4 plus 2 is 6, 6 plus 1 is 7. Okay, so I just wrote the binary for 7. And now I have to write the binary for A, which is basically 10. We found it from this table. So I'm going to be representing this in terms of the value now. So 8 plus 0 plus 1 and 0, because 8 plus 2 is 10. So I just got the binary of 10 and I got the binary of 7. And now I'm again going to merge the two together. So step 3 is that you again merge them together. So now you merge, and how do you merge? जो left पे है you write those first, 0 1 1 1. जो right पे है वो उसके बाद 1 0 1 0. And that is your answer of how you might be writing 7A in binary. Simple, easy, like literally. You just take the value, which may look very daunting at first, very crazy, very drowny, but you break that drowny value and you convert them into binary, and then you combine them. Simple. So like, for example, if I give you guys another example for you all to understand even way better, for the O-level students, I know it's just a quick revision. Jaldi guzar jayega, okay, don't worry. But let's say we have now a number like B8. How do you do this? First step, you split them. So I split B separately, I split 8 separately, and then I convert them. So I convert this into binary and I have to convert this into binary. Because the values are going to be small, I know कि मैंने 4 bits के अंदर ही रहना है. 4 slots मैंने बना लिए. I wrote the value above it, 1 2 4 8. Same 4 slots, and I wrote the value above it, 1 2 4 8. And now what I'm going to do is I'm just going to convert them. So 8 ko to ye direct 1 yahan, again all the others are 0, because now when I add them, like this gives me the value of 8. That's how I convert it. But now what is B? I don't know. So you don't have to like sort of think from your own brain. Please, in your exams, always make this. People think like mujhe pata hai B is 11, but like people mess it up, okay? People confuse C and D. They sometimes think C is 13. तो ऐसा ब्लंडर किया ना तो आप easy question पे marks lose कर लोगे, and if you lose marks on easy question, that's one of the biggest blunder you can make. So it's a B now. A B is 11. So I know that this could be written as 11. So now I'm going to write the binary for 11. How do we get an 11? 8 plus 4. Now 4 to 12 ban jayega, so that has to be 0. 8 plus 2, 10. 10 plus 1, 11. Yeah, so I got it for 11. So this part is the binary for 11. This is the binary for 8. And now what I do is I join the two together. I join this and I join this, and I get my eventual answer to be as 1 0 1 1 1 0 0 0. And that's your hexadecimal, but in terms of binary. So next time you're basically given an answer in basically hexadecimal form and you're asked to convert it into binary, not a answer, but like a question which you need to convert into binary, this is how you need to follow. These are the steps. These notes will be uploaded for you all, so you guys don't need to write this all down. But later on, these 2 examples are more than enough for you all to understand how you convert. You split all of them separately. For example, if I have to do one crazy question for you all, what if like a question comes up, which usually people get in A-level questions, that you have something like 7AC. Now you might be saying, sir, ये तो हमें किसी ने पढ़ाया नहीं है. Sir, ये तो आप धोखा कर रहे थे. So same logic. You split all of them separately. You take the 7 separate, you take the A separate, you take the C separate. So you get the 7 separate, you write the 7 up here, okay? You have the A separate and you have the C separate. Convert all of them. Write the values first. A is 10, B is 11, C is 12. So bas itne hi hai to kar diye, good C, okay? So this is basically 10 and C is basically 12. So I have to convert it back to same 4 bits, 4 bits, 4 bits. And I can basically write the values above them. 1 2 4 8, 1 2 4 8, 1 2 4 8. 7 किस तरह आएगा? 0. 4 plus 2 6, 6 plus 1 7. 10 कैसे आएगा? 8 plus 2, and the others are going to be 0. 12 कैसे आएगा? 8 plus 4 12, and the others are going to be 0. And now what you do, you combine them. So you basically just combine all of them together into the same one. So combine, let's say, all of them together, and boom, there you go. So you have 0 1 1 1, 1 0 1 0, 1 1 0 0. And that is how you convert. If you ever get like a 3-digit hexadecimal, or even if you get like a 4-digit, you split all of them this way. You convert each of them to its subsequent binary value, and then you join all of them together to get your answer in this format. That is how you convert a hexadecimal value into binary. Chat box is open. If there are any questions for this, you may ask right now. If it's 100% clear, just spam the word clear. So if you have taken O level, ये तो हलवा आपको लग रहा है. But halwa is only topic number 1. Once you get to topic 2, 3, 4, आप कहोगे सर ये तो जरा आपने रैंक कर दिया. हम तो खुश हो रहे थे कि हमें सब आते हैं, बट you're gonna see. सही है सर, जो आप अभी पढ़ा रहे हैं वो आप रजिस्ट्रेशन के बाद फिर से पढ़ाएंगे? नहीं, it's gonna continue from the part where we end the demo classes. फिर हम कहेंगे हाँ एग्जैक्टली और ये है, देर आर जस्ट 2 टॉपिक्स, लाइक आउट ऑफ द 8 P1 टॉपिक्स देर आर 2 टॉपिक्स विच जहाँ पे ओ लेवल बच्चों को चीजें पहले से आती होंगी. वन इज चैप्टर 3 एंड वन इज चैप्टर 1. इसके बगैर ऑल द अदर स्टफ यू आर गोना स्टडी फ्रॉम the basics, okay? And chapter 4 में भी थोड़ी सी चीजें आपको आती होंगी, but it's going to be like everything has to be revised and taught according to the A level format so that you understand it the right way. So now that's how you convert a hexadecimal number into binary. Okay, so is it cool if I join from August? Well, khud soch lo, if you join from August, we're going to be done with 2 to 3 topics till then, so you have to catch it up on your own. So I'm going to recommend start off early. It's no longer your O levels, better to start now than joining it late. So I'm cooked if I didn't take computer science. You know, you're not cooked, because what we are just studying is for the people who have not studied computer science. सही है? So आप लोग क्या कहते हैं, यही चीजें आपके जो ओ लेवल के बच्चे जिन्हें नहीं पढ़ी हुए उनको इसी तरीके से चीजें पढ़ाई जाएंगी. Whatever you studied in this class, this was stuff taught already in O level. So don't worry, you're not cooked at all. Everything is going to be taken this way. सर आप डेमो में मजे करवा रहे हैं, जब जून स्टार्ट होगा हमें लग पता जाएगा, तो अगर आपको लग रहा है कि मैं आपको धोखा या कुछ देना चाह रहा हूँ तो आप हमेशा लीव भी कर सकते हैं. सही है? बट या इट्स समथिंग, इफ यू डोंट वांट टू जॉइन you will most probably be regretting at the end, but yeah, of course. सही है? So it's not like मैं कोई मजे शजे कराता हूँ. It's something I always ensure कि students को समझ आए. If you're converting Denary to yeah, that's correct. You do get full marks. So no calculator in A-level CS2, not at all. God, you survive, I don't know. Allah ki dein. So that's how you convert hexadecimal to binary. I feel like we studied a lot of stuff today. We're going to continue from tomorrow understanding how, when we studied, we are saying कि हम hexadecimal से binary में जा रहे हैं. How do you also go from hexadecimal to denary? And the same way, how do you go from binary to hexadecimal? And of course, similarly, how do you go from hexadecimal to denary and denary to hexadecimal? We're going to study that alongside the uses of hexadecimal and all that stuff in tomorrow's class. Right now, I'm going to be open for question answers for the people who might want to register for our AS level session. The registration number is +92 318 177 2015. This is the contact number for Miss Naiba. She is managing all the registrations here at Conceptuals. You might get a slightly late reply if she's busy, but again, of course, you can always drop a reminder message. Don't hesitate from that. Tomorrow, inshallah, 8 p.m., we're going to have the last demo class, after which only the registered students would be able to take the classes. And for the O-level kids who think, yaar, hame ye sab aata hai, just wait for topic number 2, and then I'm going to ask you, okay? So now to the times of question answers. So we are done with the course content for today. As I promised, I'm going to stay back for max 15 minutes. So I'm going to give you 15 minutes for all types of question answers, whether it's related to the course content, A levels, anything. Aap log pooch sakte ho. So let's start off. Was this chapter 1 of syllabus? Yes, this is the start of chapter 1 of syllabus. Is chapter 1 that's it? No, abhi hai chapter 1 mein abhi bahut si cheezein rehti hai. We're going to study them inshallah. So it's not going to be ek din mein topic nahi khatam hota, okay? It's going to take time. So do you also teach A2? No, I don't teach A2 at this point. No. So what's with those reels of CS students ending up hopeless? Oh yeah, of course, with the emergence of AI, all the kids at this point are starting using AI for all their assignments and everything. So they don't know coding, right? They don't learn how to use AI. It's same as saying, okay, when the calculators were first created, mathematicians started to have a protest because they were like, oh, hamari jobs chali jayengi. But like, unki jobs gayi kya? No, Maths is one of the still most important subject out there. People do math so much. So like if CS can, the software development might vanish, you have new disciplines coming up. You have quantum computing. Have you even heard of that? We have cybersecurity in new domains. We have something more crazier coming up, inshallah, in the future, which is going to be booming the whole industry again. So don't worry at all. Okay. Inshallah, Moiz, inshallah. Sir, who will teach physics? Sir Ali Abbas, Sir Sardar Ali Abbas. So then I don't need to buy the books. I was like, no, not at all. Please, कोई books लेने की जरूरत नहीं है. School के colleges आपको दे देंगे, सही है. And क्या कहते हैं, documents provide कर देते, PDFs मिल जाती हैं, senior से ले लेना, easy सीना, you don't need to take it. Sir, what is meaning of CS? Such a wonderful question, Akbar. Such a beautiful question. I hope you get the same question on your exam paper too. And आप उधर भी यही जवाब लिखें. Keep it up. Keep it up, buddy. Keep it up. So how is NIT? So NIT, National Institute of Technology, right? If I'm not wrong. NIT, yeah. It's really good because I've heard it's something which has been promoted by one of the most senior software engineer in Pakistan. But again, I would recommend if you can get into LUMS or something like that, NUST, FAST, तो वो चीजें काफी मजे की. I was just joking, sir. I got an A. So of course, buddy, of course. Common studies may very good. Can we do A levels privately? Of course you can, but I'm going to recommend that you should go for a college because it's not only A levels in terms of the course curriculum, but it's also way more than that. You have the societies, you have friends, you have MUNs, you have those events, you interact with people, you learn a lot of stuff. So if you can, I would always encourage kids to do A levels in school. In colleges, but of course, if you have some reasons behind why you might want to do it private, 100% private because. So English, computer science, and business, is it a good combination of subjects? And it's a good combination of subjects, but what are you planning on doing in university? Because these three subjects will not allow you to be eligible for applying as an engineering major or maybe as a computer science major anyway. In तीन को पढ़ के you can go into humanities related fields. You cannot do computer science, you cannot do engineering, something like that. Sir, how is physics, CS, IT, eco? I would recommend replace IT with maths. Maths is mandatory for all tech and engineering fields. So IT को drop कर दो, take maths. IT and CS एक साथ लेने कोई तो कितनी नहीं बनती, सही है? So it's like similar to me. So after doing IGCSE, CS, and Bio CS, of course CS is for the legends, right? I love CS. Bio gone, but I hate that speaking subject, man. Literally, I had to study biology in my university first semester. में lumps में it's a compulsory course. Man, it cooked me. Both fazul subject. Ended up with a B plus though, but it was like low key so challenging for me. कि क्या बता. But yeah. Any other question, guys? Anything about the course content, or is it 100% clear? If it's clear, just calm down the word clear and it will be good. So which is a good combination if I want to be in computer science field in university? Maths, physics, computer science. The all-time best combination you can take if you want to do CS in university. Maths, physics, CS. You got interest in business or economics? Take that as a fourth subject. But maths, physics, CS, must have. How is NUST? A wonderful university. It's a really good university. But of course, I'm going to encourage every single one of you to aim for those top unis in the US, across the globe. Okay, so aim for those, make your profile. Hota hai to well and good. Nahi hua, you do have these good options in Pakistan too. Okay. Which tier is best for cyber security? Physics, CS, maths, or maths, further maths, CS? Maths, further maths, and CS might be better. Maths, further maths, and CS. But if you have to stay back in Pakistan, for majority of unis here in Pakistan, they usually expect physics too, right? That's a bit of problem. So physics, CS, maths भी रख सकते हैं. So physics, CS, सर फिर CS छोड़ के डॉक्टर बनते, maths, CS और physics का मौत है. वेल भाई फिर अगर आपको अभी ये मौत लग रही है ना, ये जो आप लोग को टीचर्स या घर वाले बोलेंगे ना यूनिवर्सिटी में मजे हैं, आप यूनिवर्सिटी पहुंचोगे, you're gonna understand कि यार A level तो मजे की चीज थी. At least like I came to LUMS and it gave me such a reality shock. I was like a straight A star student, a distinction holder, and it cooked me, it humbled me like literally. But yeah, so that's it for today, everybody. I hope we had a very wonderful class, Alhamdulillah, and that you all got to learn something new and engaging si class thi. Inshallah, see you guys tomorrow at 8 p.m. for the last demo class. And then, of course, I would love to see you all in our registered class. Once registered, you can contact Miss Naiba for registration. Once registered, you're going to be added into the demo class, sorry, for the registered classes group. And then, of course, uske baad you would be good to go. Sir, my brother in LUM says that A levels में maths लेने की जरूरत नहीं होती. This depends कि आपने करना क्या है यूनिवर्सिटी में ना, तो उसके ऊपर बहुत डिपेंड करता है कि अगर आपने CS वगैरह करनी है तो yeah, there are exceptions, but it's usually कि if you go for LUMS ने अपनी एक लिस्ट बनाई हुई है of 8 subjects which if you do 3 from them, then you are eligible for all engineering subjects. So yes, you are correct. If you do any three among those, you are eligible, but then you won't be eligible for CS or anything else and like FAST, NUS, GIK. So it's better to opt for maths. And also, if you're a CS student, maths compulsory rakho. Guys, please take maths. Uni mein, the entire CS degree is based upon maths. So you won't be studying binary. You're going to be studying literally mathematics. You're going to be studying Cal 1, Cal 2. So crazy stuff है सही है. So do take maths. So is it possible to get full scholarship outside Pakistani unis? Of course you can. Just as a fun fact, I had full tuition. I even mentioned this yesterday, but still, in US, mashallah, I had 2 full rides in Hong Kong. I had 1 full tuition also in Hong Kong, and then of course I had partial scholarships in 2 countries. One was Turkey and then one was Germany. But then I went with a conditional offer and was kismat mein ye tha ki I missed that offer from a few marks and I lost my scholarship offer. So फिर उसके बाद I ended up joining LUMS as my safety option. Allah ने हर चीज में खैर लिखी होती है. If I might have went to the US, I would have never started teaching maybe. So who knows? But yeah, Allah ke har kaam mein behtari. Just trust Allah, give it your best, and see you guys inshallah tomorrow at 8 p.m. Take care, everybody. See you everyone inshallah soon. This is your CS teacher signing off. Take care. Allah Hafiz.